Earth is often called the water world, and for good reason. Over 70% of the surface is covered in it. But here's a genuinely strange scientific puzzle. Earth may have formed in a spot too hot for water to exist at all. According to standard models, our region of the early solar system should have been essentially bone dry. So where did all this water actually come from? For decades, scientists have used a genuinely clever cosmic detective technique to try to answer this exact question. And the investigation took a real, documented scientific plot twist along the way. Let's get into it. Let's start with why this is even considered a puzzle in the first place. Early in the solar system's history, a boundary existed called the snow line. Beyond that line, far from the sun, it was cold enough for water to freeze into solid ice. Inside that line, closer to the sun, it was thought to be far too hot for water to condense into anything solid. Earth formed well inside that boundary, in the theoretically dry zone. Under this classic model, Earth should have started out essentially bone dry, with water needing to arrive much later. So scientists looked for a later delivery source, and comets seemed like an obvious first candidate. Comets are essentially dirty snowballs, packed with ice, and they regularly collide with planets. If enough comets struck the young Earth, their ice could theoretically explain our oceans entirely. It was a clean, intuitive story. For a while, it was the leading scientific explanation. To actually test this idea, scientists needed a reliable way to trace water back to its true cosmic source. Their tool of choice is called the D/H ratio, comparing regular hydrogen to a heavier version called deuterium. This ratio varies meaningfully depending on where and how water originally formed in the solar system. By comparing Earth's ocean ratio to samples from comets and asteroids, scientists can trace a genuine cosmic fingerprint. When researchers actually started measuring this ratio in real comets, the results were not what the comet theory needed. Comets like Halley and Hale-Bopp showed deuterium levels considerably higher than Earth's oceans. That mismatch was a serious problem for the simple comet delivery story. Then, in 2011, a surprising result briefly revived the Comet Hypothesis entirely. A comet called Hartley 2 was measured, and its deuterium ratio matched Earth's oceans remarkably closely. For a moment, it seemed like solid proof that comets truly could have delivered Earth's water after all. Then came a genuinely dramatic twist, courtesy of the European Space Agency's Rosetta mission. In 2014, Rosetta arrived at Comet 67P and directly measured its water composition up close. The result? A deuterium ratio roughly 3 times higher than Earth's oceans, the highest ever recorded in a comet. One Rosetta scientist reportedly reacted by saying, quote, "It was a nice story, wasn't it?" referring to the comet theory. This result strongly suggested comets, at least this type, likely weren't the primary source of Earth's water after all. With comets largely ruled out as the main source, attention shifted toward a different candidate, asteroids. Certain meteorites, called carbonaceous chondrites, come from asteroids and contain measurable amounts of water. Their deuterium ratio lines up much more closely with Earth's oceans than most comets ever did. This made asteroids the new leading candidate for delivering much of Earth's water through ancient impacts. Then, in 2020, an entirely different kind of discovery added a genuinely fascinating twist to this whole story. Researchers studied rare meteorites called instatite chondrites, believed to closely resemble Earth's original building blocks. These meteorites had long been assumed to be essentially dry, since they formed close to the sun. Careful new measurements revealed they actually contained far more hydrogen than anyone had previously realized. Their hydrogen signature closely matched Earth's own mantle, suggesting this water may have been there from the very beginning. This raised a genuinely striking possibility. Earth may have been born wet, not bone dry as long assumed. So which explanation is correct? Honestly, current research suggests it's probably a combination of several sources. Some water likely came from Earth's original building material, present from the very start of formation. Additional water was likely delivered afterward through impacts, primarily from water-rich asteroids. Comets may have contributed a smaller amount too, though probably far less than early theories originally assumed. It's a genuinely great example of science refining, and even partially reversing, its own earlier conclusions over time. This same detective approach has also revealed water exists in some genuinely surprising places nearby. Mars shows clear evidence of ancient rivers and lakebeds, along with confirmed ice at its polar regions today. Europa, one of Jupiter's moons, is believed to hide a vast liquid ocean beneath its thick icy shell. Enceladus, a small moon of Saturn, has even been observed actively spraying water vapor out into space. Water, it turns out, is genuinely common throughout our solar system, just rarely liquid on the surface like Earth's. What makes Earth special isn't having water at all. It's having so much of it in stable, liquid form on the surface. Quick pause before we continue. Take a guess. Do you think scientists have now completely settled this question once and for all? Not quite. The exact proportions from each source remain an active, genuinely ongoing area of research. Future missions collecting samples from asteroids and comets should help refine this picture even further. Let's clear up a few common myths before we wrap up. Myth 1. Scientists have definitively proven comets delivered most of Earth's water. Not accurate. Most measured comets show deuterium levels that don't match Earth's oceans well at all. Myth 2. Earth definitely formed completely dry, with all its water arriving later from space. Not necessarily true. Recent evidence suggests some water may have been present from Earth's very formation. Myth 3. The deuterium-to-hydrogen ratio is identical across every single comet in the solar system. Not true. Different comets show meaningfully different ratios, depending on where they originally formed. Myth 4. This question about Earth's water origin has now been completely and permanently settled. Not accurate. It remains a genuinely active, evolving area of ongoing planetary science research. Myth 5. Earth is the only place in the solar system known to have water in any form. Not accurate. Ice and water have been found on Mars, several moons, and likely many other bodies too. Myth 6. Asteroids are always completely dry, rocky objects with absolutely no water content at all. Not true. Certain asteroid types, like carbonaceous chondrites, can contain meaningful amounts of water. Let's wrap up with a few fun extra facts. Some of the instatite chondrite meteorites studied in 2020 suggested enough water to fill Earth's oceans 3 times over. Space agencies have sent missions specifically to collect samples from asteroids like Bennu and Ryugu to study this further. These return samples let scientists study genuinely pristine material, without any contamination from Earth itself. Water only makes up a tiny fraction of Earth's total mass, despite covering most of the visible surface. It's a genuinely striking reminder of how much scientific mystery can hide behind something as familiar as ordinary water. Okay, let's bring this all together. Earth likely formed too close to the Sun for water to naturally condense there in the first place. Comets were the first major suspect, but most measured comets don't match Earth's water signature well. Water-rich asteroids became the leading delivery candidate, matching Earth's deuterium ratio much more closely. A 2020 discovery suggested some water may have actually been present in Earth's original building material all along. The current best picture is a genuine hybrid, some native water, plus meaningful later delivery, mostly from asteroids. All from one substance so familiar, most people never stop to wonder where it actually came from. If this answered a question you never knew you had, that's exactly what this channel is about. So if you enjoyed this, hit subscribe so you don't miss the next one. It genuinely helps this channel grow, and it takes about 2 seconds. Drop a comment and tell me which part surprised you the most. Was it the Rosetta twist? The native water discovery? Let me know. And if you like this video, go ahead and tap that like button. It's a small click that genuinely helps this channel keep growing. There are hundreds of everyday questions just like this one waiting to be explored. Things about our own planet you've never actually stopped to question. That's what this channel is all about. Toggling your curiosity on, one question at a time. One more thing before you go. Tap that notification bell too, so you actually see it when the next video drops. Next time, we're tackling why flamingos stand on one leg for hours without falling over. It's a surprisingly clever energy-saving trick, and you will not guess the mechanism. I'll see you in the next one.